Okay. So tell me, like before discussing these basic principles and basic concepts about organic, just quickly tell me what are the formulas or whatever the topics that we have discussed from physical chemistry. See, we have discussed about mole concept. Okay. So there specifically we have got some relations between weight of a substance, like given amount of a substance, with the number of moles. So with the help of this number of moles, we can get to know how many particles or how many atoms are there in the given weight of substance. Like we have related number of particles. For example, what do we mean by particles here? See, if I say that there is a 12 grams of carbon in my hand, okay, so it contains, it means 12 grams of carbon is nothing but 1 mole of carbon, you are saying. 1 mole of carbon is nothing but it contains Avogadro number of particles. This is how you have simply understood the concept right now. Okay. So now slowly, it means from tomorrow onwards, almost I am going to start the regular lectures, I mean chapter wise. Okay. So this is the last class for your basic understanding. Like, just tell me, like any difficulties are there in understanding of any of these concepts, or having any confusions, you tell me, I will discuss those today. Okay. So is this relation is clear? Like number of like given weight of substance to number of moles to number of particles. Okay. And one more thing, when I start any new chapter, there also whatever the basics are required, I will discuss there also. Those who are newly joined, don't think that everything we have discussed in the last classes. Okay. Right. The next thing, for example, okay, see, some substances will be there, they will exist in the gaseous form. Like we know matter can be in the solid, liquid, gaseous state right now. Okay. So any of that substance, we can simply mention them as weight of that substance. For example, I have a solid substance, I can say its weight, or a liquid substance, I can say its weight. Okay. Similarly for gas also we can say, but mostly when we discussing about gases, we will discuss in terms of its volume. Like 2 liter gas is there, 5 liter gas is there, like that we will discuss. Yes or no? For example, LPG gas is there at our home. So what you will say? Like generally it will be termed in terms of like liters. Yes or no? Otherwise, like vehicles will use CNG gas, they will also term in the term, like they will also say terms of liters. Okay. Any gas if you take, it will be in that form only. Okay. So now you take any gas. What I am saying, you take any gas at particular temperature and pressure, at STP condition I am saying. What is this name? Standard temperature and pressure. So standard temperature is how much here? 273 Kelvin. Okay. And what about pressure? 1 bar pressure. How much it is? 1 bar pressure. Okay. Now there is one more term called at NTP. What they will say? NTP. So here temperature is same 273 only, so 273 Kelvin, but pressure will be 1 atm. How much pressure? 1 atm. See, temperatures are same but pressures are different. Okay. But STP means at that particular condition, temperature and pressure are fixed. Yes or no? So at this fixed state, or at this fixed condition, 1 mole of any gas, what I am saying, 1 mole of a gas occupies 22.7 liters. How much volume it has? If I take 1 mole of a gas, it occupies this much volume. Okay, 1 mole of a gas occupies how much volume? 22.7 liters. At what conditions? STP condition. So if I change little bit in either temperature or pressure, this value also changes. That's why we should say 22.7 liter only at STP condition. See, now from 1 bar to 1 atm pressure, just a slight difference is there. By changing this, 1 mole of any gas occupies 22.4 liters. See, pressure changed, volume occupied by the gas also changed. Okay, it means at a specific temperature and pressure, 1 mole of any gas or the fixed amount of any gas will occupy same amount of volume. ఒక టెంపరేచర్ ప్రెషర్ దగ్గర ఏదైనా గ్యాస్ తీసుకోండి, సేమ్ క్వాంటిటీలో గ్యాస్ తీసుకుంటే దట్ విల్ ఆక్యుపైస్ సేమ్ అమౌంట్ ఆఫ్ వాల్యూమ్. ఈజ్ దిస్ క్లియర్ ఆర్ నాట్? ఏదైనా కన్ఫ్యూజన్ ఉందా? నో. ఓకే, ఫర్ ఎగ్జాంపుల్ I am saying amount, same amount, that amount should be mentioned in terms of moles only. Okay, for example here 2 grams of H2 gas, I am saying 2 grams of H2 gas at STP, at NTP, let us say at NTP, okay, occupies how much volume I am asking. See, most of the students here are for mostly EAPCET or NEET. There will be 4 options, I mean while doing the questions, numericals, I mean MCQs only, no? So for like simplification purpose, you just take whether they mention STP or NTP, you just mention this 22.4 liter, almost same values, no? You will get exact number only, okay, because all these numbers are even, here one is odd is there, so while calculating you will feel difficult right now, so you can take this also, you will get the value, okay, nearest value you will get, you can tick it. Okay, right. Now tell me, 22 grams of H2 gas at NTP occupies how much volume I am asking? What to do now? First tell me. Given weight is there. What I told you, given weight, convert into moles, convert into Avogadro numbers if they are asking number of particles. Or if they ask about volume, what I told you, 1 mole means 22.4 at STP, at NTP, like that. So now 2 grams means first what we need to do? Number of moles of H2 is how much now? Given weight is 2 grams. Molar mass of H2 is 2 only, 2 gram per mole. Okay. So same thing even after starting the class also, in the next session also I am going to discuss these things only, but we'll going to extend the further topics. Okay, right. So how many moles we are going to get here? 1 mole of H2, it means 2 grams of H2 means it is nothing but 1 mole H2. So 1 mole of H2, hydrogen is a gas, liquid or what at normal temperatures, okay, at STP. So it's a gas, okay. So 1 mole of this H2 gas occupies how much volume now? 22.4 liters. Is this clear? My student is commenting. Okay. So now same amount I am taking. See, 2 grams of H2 means how much volume it is? 22.4 liter at an NTP condition. Now for example, I am taking same 2 grams of, okay, let us increase the quantity otherwise. Okay, how much will take? 16 grams of H2 I am taking. How much? 16 grams of H2 at STP or NTP, let us say. NTP we are taking. So how many moles it is? How many volume, how many liters it is? Or what is the volume it is at NTP? Same 16 grams, this is first question. Second one I am saying, same 16 grams of O2 I am taking. O2 at STP or NTP. So tell me what is the volume occupied by these gases? First and second question, tell me. Yes, tell me. 79.2. Huh. So 16 grams of N2 means what we need to do first? First convert into mole. 16 grams by 2 gram per mole. This is the molar mass. So this is 8 mole. So 8 mole means 8 into 1 mole means how much? 22.4 liters. So you can multiply, you will get this answer. Okay. Next, what about this? Tell me. 16 grams. Given weight of O2 is 16. By its molar mass is 32. So it will be 1 by 2 moles. Moles of O2 is 1 by 2. Half mole we got. So half mole at STP, at NTP. How can you write? Half into 22.4 liter. So this will be 11.2 liters. Okay, is this clear? Okay. So now what you need to understand here, see whether the weights may be same but volume will be maybe different because their molar masses changes. But if the number of moles are same, for example 1 mole O2, how much volume it occupies at NTP? At NTP, how much? 22.4. If I say 1 mole H2, how much it will be? So if the number of moles are same, the volume of gas occupied will be also same. But if the weight of the substance may be same or like they can be same, the volume changes. It depends on what? Number of like molar mass is different, that's why its volume is changing here. Okay, so don't think that quantity is same means value will be same. Just connect it to moles, then you can get the answer. Okay, done. Next, now if I say instead of 22.4 liter at NTP means how much like quantity it is, how many moles it is? 1 mole you can get. Okay, now I am saying you 5.6 liter at NTP. Tell me how many moles it is? 22.4 liter means 1 mole you are saying. 5.6 liter at NTP means ఇక్కడ నుండి ఇక్కడికి ఏం జరిగింది? See, this number changed into this one. Okay, I am asking you x moles. So in the first class I told you to do unitary method. Do you remember what to do? Like something like x into 22.4 equals to 1 into 5.6. If you divide that, x will be, once again you do that once again. Yeah, it will be something like 5.6 by 22.4. It will be 1 by 4. 1 by 4. It means 22.4 liter means half mole. 5.6 liter at STP at NTP means 1 by 4. Are simple. From here to here, how can we convert? By dividing with 22.4 divided by 4 is how much? Same number you divide here. Divide with 4, so it will be 1 by 4, that's it. It is 1 by 4 moles. Is this clear? Okay. So the next one more thing I will ask you. Saying you 14 grams of N2. N2. So now what is the volume at STP? At NTP? How many liters it is? 11.2. How to do this? 14 grams I have given now. So given weight by its molar mass will be giving you half mole. Okay, half mole means 1 mole means 22.4 liters. Half mole means 1 by 2 into that 22.4, that is so 11.2 liters. Is this clear? Okay, next. Okay, so now tell me one more question. This is one last question, then we will discuss later. 5.6 liter of N2 at STP or at NTP has weight of how much dash grams. How much weight it will be? Okay, so tell me what is the answer? So how you are doing this, tell me? 5.6 liters they have given now. See, they are asking about weight. Okay, now what is the relation between volume at NTP they are mentioned. See, this story whatever we discussed till now applicable only at STP, NTP conditions. Okay, so now we know 1 mole of N2 gas at NTP occupies 22.4 liters. 1 mole N2 means what is the quantity, like they are asking weight now. So tell me. 28 grams. Like 28 grams now, because they are asking relation between weight and volume. So we have weight this side, volume this side. Okay. So 28 grams is nothing but 22.4 liters of N2 at NTP condition. Now how much volume they mentioned? 5. So 5.6 liter. This is X. Tell me the value of X here. So use the unitary method I told you. So what is it? Like 5.6 into 28 equals to X into, upon simplifying, 7 grams you got. Okay. So now one more thing you can do like this also. See, from here to here, how many times it is divided? 4. So from here to here also, if you divide this by 4, you will get the answer, no? How much it is? 28 by 4 is 7 grams. Is this clear? Very simple mathematics. Okay. Right. Let's move forward. Okay. Okay. Let's discuss about organic chemistry here. See, most of the students like they won't touch organic chemistry. I don't know why it is. Okay. So they, before starting itself, they have a phobia that we can't do this. We just leave it. Even for IP exam also, you feel like it is hard to remember. So we'll only go with, if it is second year, we'll only go with chemical kinetics and electrochemistry and P block, and leaving it for option like 8 marks question. Right now, mostly the people will do like this. But you know, once you study it properly, okay, this will be very easy. Even it is easy when you compare with other topics. Okay, it includes only concepts. I mean, proper concept it will be. Like if you have proper basic, then no need of knowing the name of that reaction also. You can only do on your own. Okay, so we'll definitely you are going to make it clear. Like you can go, like you are going to like it very much once after completing our organic classes. Okay, if you follow them properly. Okay, so firstly, so as of today we will discuss a little basics about organic, like IUPAC name and some basic reactions. Okay, so first one, so what do we mean by the word organic means? It's something like a natural source. Right now, Organic means what? It is something like species or the compounds coming from the natural sources. For example, like human waste, okay, or animal waste or animals or whatever it is. From the natural source it should come, right now. Okay, so when it comes to inorganic means, they comes from non-living things. Non-living things means generally like minerals. You have studied about metallurgy in class 10th also you have studied. So it deals only with the things that are comes from like non-living sources, like from the earth crust and all those things, right now. Okay, so here at the very beginning what they thought, organic chemistry means we cannot prepare them synthetically, we can only extract them from some natural sources. That's why they have given the word organic. For those compounds which are coming from natural sources are considered to be organic compound. But later, as the developments in the scientific research goes on, there are some compounds which can be synthesized in the lab also, which are organic compounds. So who is that first person synthesized these organic compounds? His name is Wohler. And what is that compound? Urea. So urea is the first compound synthesized in the laboratory. Okay, and we know urea has very vast number of applications in our agriculture fields right now, like a fertilizer. Okay, so now here, before even starting the chapter itself, I will be asking you one question that we can expect from this compound. Now what is the question they will ask is, first of all, find its molecular weight. What is the molecular weight of urea? What is the question they are going to ask you from this? What is the percentage of nitrogen in urea, they will ask. What they will ask? What is the percentage of nitrogen in urea? Okay. Molecular weight is how much? I hope you know how to calculate molecular weight. Okay. So tell me, 2 nitrogens are there, 2 into 14 plus 1 carbon is there, 1 into 12. 4 hydrogens are there, 1 into 4 plus 1 oxygen is there, 1 into 16. Upon simplification, 28 plus 12 plus 4, how much it is? 60 we got. 60 gram per mole is the molar mass of urea. Now what is my question? Percentage of nitrogen in urea. Okay. Now what is the total mass we got? 69. That is total mass over here in the denominator. Now what I am asking? Percentage of nitrogen. Now what is the quantity of nitrogen in this? 14 to the 28. So 28 into 100. Okay, that's it. Upon simplifying, you are going to get percentage of nitrogen. In the same way, you tell me what is the percentage of carbon if I ask in the urea? 12 by 60 into 100. Do you got what we are doing here? Even if I ask what is the percentage of hydrogen?
4 by 60 into 100.
You got this concept now? Fine. Now, there is a question I have seen. The same question appeared in, you got this concept now? The same question appeared in your NEET exams also, and even the same question is repeated in the IIT JAM BT, biotechnology students will write. So there also it is repeated, because you are the bio students who deals with enzymes right now. Okay, so there some enzymes contains like metals in the middle. For example, hemoglobin, if I talk, there will be iron in the middle. So now they will ask you, what is the percentage of iron in the hemoglobin? They will ask you. So what we need to do now, tell me? Total weight of that compound. Here, what is the weight of iron into 100? Got this concept? Yeah, that's it. Okay, I am erasing this. Yeah. Okay, and after this Euler, there are other compounds also prepared by other different scientists. Okay, anyways, so we'll study little bit about them if it is there, otherwise we'll move forward. See, and the next acetic acid by whom? Kolb's. Okay, so on this person's name, Kolb's, so we have two reactions. One is Kolbe's electrolysis and Kolbe's reaction. So you have studied along with the Riemer-Tiemann reaction. What is the reaction? Tell me fast. Salicylic acid will be formed. Riemer-Tiemann means salicylaldehyde. Kolbe's reaction, salicylic acid. There it is salicylaldehyde, it is salicylic. Now tell me what is the reaction involved? Phenol react with carbon dioxide in basic medium like NaOH, okay, and gives you orthosalicylic acid, means at ortho position. Phenol, you know the structure of phenol? So what is the structure of phenol? So at this position we are introducing COOH, that's it. This is salicylic acid. Now if I say salicylaldehyde, CHO, that's it. Okay, this is ortho product. These are two ortho products. This is formed in Riemer-Tiemann reaction. This is in Kolbe's. Okay, now sir, we can also get para product also, but ortho is major. Why they will be asking why it is major? Because there is a hydrogen bonding between this OH group and this oxygen of this CHO, and here also oxygen of this carboxylic acid. Okay, so due to that intramolecular, within the molecule hydrogen bonding is taking place. So due to that reason ortho products are major, you can remember. Okay, now they will ask you one question. See, it is better, since it is a crash course, wherever there is a chance we should discuss there itself, because we can expect question from anywhere. Okay, now tell me what is the electrophile in Kolb's reaction? Just now you told phenol reacting with NaOH, CO2 in presence of NaOH uses. So carbon dioxide is an electrophile in Kolb's reaction. What is electrophile? I am going to tell you what is this electrophile nucleophile after some time, just remember. Next, in this reaction they will ask what is the electrophile involved or what is the reagent involved. See, what is the reagent involved in Riemer-Tiemann reaction, tell me? Chloroform is a reagent, but from this we are going to get dichlorocarbon, CCl2. This is a electrophile. Okay, so in Riemer-Tiemann reaction we are using chloroform in presence of NaOH reacting with phenol gives you salicylaldehyde. Here phenol with the carbon dioxide gives you salicylic acid, that's it. Okay, electrophile here is CCl2, here it is CO2, that's it. Okay, in which chapter we will be studying this? Alcohols, phenols, ethers. Okay, next. Okay, remaining reactions we will study. Okay, so let us start with very basic thing. So structural representation of organic compounds. See, I can represent the structure like this. Now organic chemistry is what? It is not only coming from natural sources, but it can be also synthesized in the laboratory. Now there are some lakhs, crores of compounds we have, and still they are keep on synthesizing new compounds, and those are playing very crucial role in medicinal chemistry, industrial chemistry and all those things. Okay, so this is the simplest hydrocarbon. So what do we mean by hydrocarbon? Hydrogen, carbons only present in the molecule, so considered as hydrocarbon. So this is the simplest hydrocarbon molecule we know. Okay, what is its name? Methane. Methane. Okay, so now here when it comes to hydrocarbons, something like this, we have three names. What is this? Alkane, alkene, and alkyne. Okay, so now alkane means what is the general formula we can say? CnH2n. Now tell me what is the valency of carbon? 4. Tetravalency we are saying now. So it means around the carbon all 4 should be sigma bonds only. Then we can say it as a alkane. So for that, see, CnH2n plus 2 is the general formula of alkane. Okay, what is that? So now when it comes to alkene, so it will be, just tell me one example for alkene. Methane is over, little bigger. C2, put here C2, H, 2 to the 4 plus 2. 6, C2, H6. Now tell me with 4 carbons. Formula. C4H10. Okay, right. Now what about this? Alkene. There should be, see, in alkane's case, what I told you, there should be all sigma bonds only around the carbon. But when it comes to alkene, there should be at least one pi bond, between the two carbon atoms. Okay, so it means like C double bond C. Okay, now what is the general formula? See, in order to make this double bond, see, just write the formula of this structure of this ethane. Like this we are writing, this is ethane, no? See, all bonds are sigma bonds only, single bonds only. Okay, in order to make one pi bond between the two carbons, how many hydrogens I should remove from there? One from this carbon, another one from this carbon. Two should be removed so that I can make a double bond over here, because carbon maximum forms 4 bonds. So that's why I'm removing these 2 hydrogens, I'm inserting a pi bond. So it becomes, so 2 hydrogens less now, so it should be CnH2n only. This is a general formula. So give an example, C2H4. So carbon, 4 hydrogens. Like this. Is this clear? Okay. Next, tell me for alkynes. There should be 3 bonds between 2 carbons. At least one multiple, like 3 bonds between 2 carbons. Tell me. Cn minus 2. Give an example. C2H2. Okay, one more example. C4, tell me. Fast. C4, 4 to the 8 minus 2. H6. Okay, like this. Okay, up to here this basic thing is clear now? Yeah. So now, there are different ways of representing the compounds. Like I can write like this bond line notation like this, or I can write in this condensed form. Condensed means I am not representing any of that bonds. Okay, the next one like this one is what? Bond line structure. So I'm not representing like this complete structure. This is complete structure, like representing every bond and atoms. Okay, and this is what? Condensed notation I can say. Condensed notation means I can write like this, CH3, CH3. See, I am not representing bonds, but I am representing atoms. Here everything is represented. When it comes to bond line notation, there is only writing the bonds that are present between carbon atoms. So for example, ethane is there now, I can simply write like this. Propane is there now. How many carbons are there in propane? 1. See, this terminal is 1, second, third. That's it. This is propane. Okay. So tell me, since we are at the beginning, we feel it is easy to write like this. But once you become pro, it means you become masters in that. So it is time consuming now, like writing all these structures. See, if I say decane, how many carbons you should write? 10 carbons. It is very difficult to write like this. So here if I ask, you just put like this, like 10 carbons, it's over. Okay. So which one we will prefer now? Bond line notation. Okay. Right. Huh? Right. Let me go through. So let us write for butane. Tell me, how do you write for butane? 4 carbon. 1, 2, 3, 4. Okay. So this terminal side is there now. So for example, this is propane, I told you. So if you want to write CH3, CH2, CH3. So at the terminal, it means every this end terminal should be considered as methyl group. What is that group? Methyl. At this middle one here, this one, this is called methyl, this is called methylene. What is this? Methylene. Methylene. Okay, next. Okay, so you know little bit about IUPAC nomenclature. So I am writing 2-methyl. Anyways, I will discuss those, but just you need to know this bond representation first. 2-methyl butane I am writing. Tell me, how do you write this? So this is butane. First write this parent chain like this, and this is substituent. At which position? Second position. That's it. Okay. Now what is this carbon here indicating? C. Now tell me, if I want to write condensed form, what it should be? CH3. And this middle one? That is why. CH only. Okay. This side? This one? This one? Is this clear? Okay. Now, why I am particularly asking, some people might be thinking, Arey yaar, we know this, why he is teaching like this, I mean very basic. Some people may think. But see, I can raise the question. Now here, this is how the questions will come out. See, they will ask you, number of types of carbons in the given compound. Types of carbons. How can you say this? Tell me, in this compound. See, this is a methyl group, this is also methyl group, this is also methyl group. But all these 3 methyls are same? No. Why they are not same? Tell me. Nothing like condensed here. I am asking their nature. See, this methyl attached to a carbon here having how many hydrogens? 1. It means these 2 might be of same type. Let us say they are A type. But this methyl attached to a carbon having 2 hydrogens. It means these 2 methyls are same now? No, right? This fellow having only carbon with 1 hydrogen and this is having 2 hydrogen. So it means it is not a same as like this. So it should be a B type. Okay? And now this is another, like only 2 hydrogens are there, here 3 are there. This is C and this will be D. So how many carbons, how many types of carbons are there? 4. Is this clear how we are identifying them? Okay. Now one more thing. If a carbon having only hydrogens, normally we are saying methyl, okay, and there is a carbon with like methyl group is there and here some chain is there that side. So on this carbon now, how many carbons are present? This side carbon, it means it is continuing that side, just don't consider about that thing. So how many carbons directly attached? 1. So it should be called as a primary. What is that? Primary. Now if the carbon contains 2 methyl groups or 2, it's not only methyl group, at least 1 carbon should be there the other side. Then tell me what is the degree of this carbon? 2. How many carbons are there? 2 carbons. Like directly attached, how many carbons to this? 2. So it means it is a secondary. Now let us clarify little more. Tell me what about this? Arey, this is also 2 degree only, secondary only. Why? What I told you, it's not about the chain. It is about number of carbons directly attached to this. How many attached? 2. So it should be also secondary. Is this clear? Okay. Next. Not clear? Arey. See, to this carbon, how many carbons attached, ma? 2 carbons. So it should be a 2 degrees, secondary. Here also, to this carbon, how many carbons directly attached? 2. Here 1, here 1. It's not about, sir, here 1 more is there. Don't worry about that. To the discussing carbon, to our carbon, how many are directly attached? 2. It means it should be secondary. Is this clear? Now, like this it is there. To this is what? 3 carbons, so 3 degree, tertiary. Okay. Now, to our middle carbon here, how many attached carbons are there? 4. Directly attached, 4. So it is a quaternary. Okay. Is this clear? Okay. Now come to this formula now. Tell me, what is this degree of this carbon? Fast, everyone. To this carbon, how many carbon is attached? This one? This one? 1, 2, 3. So it should be a this one? Secondary. This one? Primary. Is this clear? Okay. Now same structure I am writing like this. Tell me here also. This middle one? Tertiary. This? This one? Primary. Is this clear everything? Sir, you are saying this is primary, this is also primary, but you are saying they are different. Yes, they are primary, but are they same? No. Why not same? Because adjacent attached catamas, secondary here it is tertiary. That's why they are different. Primary only. Primary lo, mali different. Okay, అర్థమైంది ఇంకేమైనా కన్ఫ్యూజన్ ఉందా? Are you able to identify them? Yes. Okay. Yes. Tell me for this. This one? This one? This one? Nice. This one? Clear na? Yes. Okay. Again, you remember this. We will discuss after 15 days again. When I start organic, it will come. Don't put the dumb faces at that time. Clear na? Or any confusions are there? Okay. Okay. Let us discuss. Let us classify these organic compounds. See, if you see first compound, if you observe, I have written in the open form, like this. Like this I have written. Okay. And the last one that we have discussed is something like this. Okay. So it is like a ring, cyclic ring. Okay. This one is okay. So now this is a open chain form, this is a cyclic form. So what we are doing now? Classification of organic compounds. It can be open or it can be cyclic or ring compounds we can say. Okay. So these open chain compounds are also called as acyclic. If it is cyclic, it should be called as acyclic. Example here we have written butane, propane, pentane, all these things. So here it comes cyclic, like cyclopentane, cyclobutane, cyclopropane. It means for cyclic compounds, the name should start with cyclo. Okay, next. Now if you observe, whatever the compounds I have written on the board till now, except urea, all other compounds are hydrocarbons only there. Is there any other element other than carbon and hydrogen? No. But in urea, you have seen something like nitrogen and oxygen. So if an organic compound contains carbon and hydrogen only, you should call it as if along with this any other atom is there, like nitrogen, oxygen, sulfur, any other element is there, you should call it as a heterocyclic compound or hetero compound. What is that? Hetero. If it is cyclic compound, heterocyclic compound. If it is a open chain form, hetero compound. Okay. See here again one more thing. Cyclic compounds I am saying now, if that cycle contains only carbon atoms, that should be called as homocyclic. if that cycle contains, if that ring contains any of the heteroatom. For example, like this I am writing. Now 4 carbons are there, 1
Oxygen.
so is this homocyclic or heterocyclic?
Heterocyclic.
So it comes under heterocyclic. And what is the name of this compound?
Cyclic.
Okay, fine. So you call it as tetrahydrofuran, THF. Okay. Next, homocyclic is over, heterocyclic is over. Next one. Now, when it comes to like cyclic compounds, there is a specific classification called aromatic compounds, non-aromatic compounds, anti-aromatic compounds, like this. Okay. Generally, when it comes to cyclic compounds, organic compounds, aromatic compounds are highly stable. What they are? Highly stable. And we can expect one question directly from aromatic compounds, like identifying aromatic compounds in any exam that you are going to write. Okay? Right. So I will explain that very clearly and very simple way when we are discussing that. Okay. So now aromatic compounds, like if there is at least one benzene ring, see benzene you know now, what is the formula? C6H6. So if there is benzene ring, this is aromatic. Okay. So if there is like a benzene ring, you can call it as benzenoid compounds, like benzene and some bigger rings including benzene, if it is there. See, for example, phenol is there. There is a benzene ring or not? So it should be benzenoid compound. Okay. Now there are some compounds without having benzene ring, they are aromatic. For example, see what I am writing. This is a compound. Are you seeing any benzene ring in that? Is this a benzene ring? No, no. Benzene means how many carbons should be there? 6 carbons, it is something like this. But here you can see only 4 carbons, 1 nitrogen, like this we have now. So this is not a benzenoid compound. It is considered as non-benzenoid compounds. So aromatic compounds can be benzenoid, non-benzenoid. So these are some examples. This is bigger, you might feel scared, that's why I am writing smaller one. Okay. So these are considered as non-benzenoid, benzenoid. Is this clear? Okay, that's it. Okay, further classification and all we'll discuss. But up to here it is clear now? Any confusions are there? No. Okay, let's go for the naming. When it comes to names, there are 2 types of nomenclature. One is common names, another one is IUPAC name. Common, or we can also say trivial. Common and trivial. So common names comes from their origin. Like for example, you know formic acid. What is the formula? HCOOH. Okay. So this will be present. Like have you experienced any time like ant biting or bees biting? Okay, how you feel? Like sensation, like burning sensation it will be there, no? So that is because of this formic acid. Okay, so ant actually in Latin it is ants are called as a formica. What is it?
Formica.
Since it is coming from this compound is coming from formica, we are calling it as formic acid. Okay, like this. Based on their origin or based on the person who have synthesized that, it might be given on that or based on the origin, especially on origin. Okay, from where it is derived. Okay, based on that we are giving common names. But tell me, now there are lakhs of compounds. Is it easy to remember that names? Is it possible? It's a highly difficult thing right now. Okay, so that's why an international organization came with some specific rules to be followed, so that if you say that naming, everyone can identify the compound wherever you go. Okay, so now instead of saying this is a formic acid, I can say now following IUPAC name as, following IUPAC rules as methanoic acid. What I can say? Methanoic acid. So what is the IUPAC name of this compound?
Methanoic.
Common name is?
Formic acid.
Okay, like that. Okay, so now here you can see this is what? Carbon, only one carbon is there, means what we should say? Methane. Okay, let us go with that. Okay, if only one carbon is there means only one carbon atom is there. So you can say methane. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like that. Okay, it goes on. Okay, so instead of writing, see, this is what? If I remove one carbon, one hydrogen from here, so it means what is the valency of carbon? If all 4 valencies are satisfied by only hydrogen, you can say it as a methane. But if one of this hydrogen is removed, now this carbon is attaching into someone else, some other compound. So now you should call it as the CH3 is there now, like this it is connecting. You should call it as a methyl. What is that? Okay, if there is an alkane, from alkane, if I remove one hydrogen, it becomes alkyl. Is this clear? For example, butane, propane, like that we should call. Okay? Okay, right. Next one, let us see some common names here we have. Okay. So if there is a straight chain like this, butane means how can I write, ma? Like a straight chain I can write. Okay, is there any other possible way to write the structure? Yes, not closed. Okay, I will tell you why not closed is not possible. See, this is a butane. Say, oh, like a straight chain is there, na? Now with the same, what is the formula of this? C4H10. With the same formula, I can make 3 carbons like this, and now I can put 1 carbon over here. Okay, both of them have same formula but differ in their structure. These are called isomers. Okay, and differ in the structure, no? So structural isomers we will say. But this is a straight chain. So when you are writing a compound in the straight chain, sleeping up. Okay, so you will get the name as N-butane. What is that?
N-butane.
Okay, but here something like a branch is there. See, in the main chain 1, 2, 3 only there. So if it is something like this, so you should call it as iso. See, isobutane. How many carbons are there? 4. Isobutane. Okay, now tell me this one. How many carbons are there? Okay, what is this name? N-pentane we should say, like straight chain now, N-pentane. Now what I am doing, what you should call? If this kind of fragment is present, isopentane. See, now the same thing I can write like this. Is the same, na? Yes, they are same. Isopentane only, both of them. Okay, see, not position, everything is same. I have written, I have just flipped like this. Then the take this and rotate like this. Both of them are same only, na? So it is called as isopentane. Okay, when it comes to IUPAC name we will discuss. Okay, now with the same formula, now what I am making, see, I am writing a middle carbon here. This side one CH3, this side another CH3. Here one CH3, one more over here. So now tell me how many carbons are there? 5. So 5 carbons are there now. It means definitely pentane. But what is the common name of this compound is neo. When we have a carbon like this, it should be called as a neopentane. Now remembering the neopentane structure is very important. Okay, why? Because if you observe methane, what is the formula of methane? How many types of carbons are present in methane, they ask? 1. if I replace all 4 hydrogens with methyl group, what we got? Now they will ask, how many types of carbons present in neopentane? How many types of carbons? 2 types. What are those? The middle one is there na? That is quaternary. These all 3 are same. So primary. Now one more question. How many types of hydrogens present in methane? All of them are same, so 1 type. Now how many types of hydrogens present in neopentane? 1 type, because all of them are like methyl, methyl, methyl only, no? So same. Is this clear? Okay. Next. Like this we have like acetone, chloroform, all these are some common names. Okay. Next. Okay. So tell me, let us discuss a few structures here. What is the common name you have told me before? Isopentane. Isopentane. Now what is the IUPAC name of isopentane? Huh? See, your numbering should be done. Like first identify the longest carbon chain. Like this we have, or like this we have. Okay, like 1, 2, 3, 4. Longest hydrocarbon chain. Okay, so I can number from this side and from this side. But wherever there is a substituent, that should get a minimum number. So that's why I'm starting from this side. So 1, 2, 3, 4. So at which position we have that substituent? 2 methyl butane. 2 methyl butane. Okay. So now it is clear. Okay. So that longest carbon chain we are saying now, that is called word root. Our parent chain is there now. So the name of that parent chain is indicated as what? Root or root word. Okay, this is middle. Okay, let us put like this. You know, like English grammar, you know now. There we'll use something like suffix and prefix. Suffix means after. Okay, prefix means before. Okay. So here we have prefix to this word root. Front one is prefix, back one is okay. Now I am dividing this prefix into 2 parts. Okay, prefix 2 parts, suffix also 2 parts. It starts with 2, ends with 2, and here 1, 1. So secondary prefix, primary prefix, root word, primary suffix. How you will remember the structure? First root word, prefix, suffix. Starts with 2. Okay. So now what do we mean by 2 here, 1 here? See, these are both of them are prefixes. But for example, see. Here what you have written? Prefixes. 2-methyl is a prefix, like substituent. So now if there is only substituents like this, like alkyl groups or any other like chain is there, okay, that should be written as a secondary prefix. What I am saying? But there are some compounds, cyclic structure will be there, or 2-3 cycles will be there, ring structures will be there. So that comes under primary prefix. Okay, what it is? Primary prefix. Don't worry, I will give some examples. You just listen here. Okay, write the name of this compound. If I ask, what will be its name? From where we should number it? From my side or from that side? From my side. Why? Because it will get a minimum number, 2. So 1, 2, 3, 4, 5, 6. So tell me. How many methyls are there? 2 times now, so di. First letter should be capital. Okay, 2, 4 dimethyl hexane. For this one you tell me. So this is what now? So 2, this is what now? Prefix. I mean prefix. Which prefix? secondary prefix, and there is no primary prefix here, so no need of classifying it secondary, primary like that. But come to this, yeah, okay, now tell me. 1 comma 2 dimethyl cyclopentane. So what is our root word in this name, tell me? Pentane is a root word. So is this clear? First of all, pentane is a root word you are saying. Okay, see what root means, actually not pentane, pent is a root word. Okay, remember. So up to here it is clear now. See, root word comes from the longest hydrocarbon chain, like number of carbons in the longest carbon chain. 5 carbons are there. What is the name? Pent. 6 carbons. Like that. Okay, so it is 5 carbons, so it is pent. Okay, root word is what? Pent. Now I am discussing only prefix first. Let us make it clear. So before this word root, what are the terms you are saying? One is dimethyl, another one is so I told you one is secondary prefix, another one is so now dimethyl is there now, that is secondary prefix. The cyclo is there now, primary prefix. So in a given organic compound, if there is something like cyclic or bicyclic or something called spiro, if it is there, then we should call it as comes under primary prefix. If any substituents are there, then comes under secondary prefix. Is this clear or not? Still having confusion in understanding? No confusion, na? Spandana? Is there any confusion? Okay. Now we need to discuss about suffix. So suffix means, okay, look at this. Okay, I don't want to make it complicated. Okay, so tell me from where we should number it. See this other than carbon hydrogen is there now. So what is that? OH. So now that is a functional group. Okay, functional group. What is the use of functional group? It decides what is a chemical property of that particular compound. So for a given compound, its chemical properties or physical properties will be determined or given by that functional group. Okay, for example, we have like alcohol is there. So where we are using it, like in sanitizer, we are using or not? Okay. So instead of using alcohol, if we use some acids, what happens? Yeah, it might cause some irritation or inflammation, whatever might be. So that in disinfectant properties are because of hydroxy group. Okay, that is what the main aim of functional group. Okay, so now whenever there is a functional group, start numbering from that side. Okay, so it means you should number only carbon atoms, not that oxygen atom. So from where I should number? From here. 1, 2, 3, 4. So now tell me what is the name? How many carbons are there? Okay. So tell me. But 2 in one ol. Okay. So tell me, word root. What is our word root? After that I have started writing. So what it is? Suffix. There are two things are involved. In, ol. Okay. So this in is indicating whether it is alkane, alkene or alkyne. So our primary suffix indicates what? Whether it is alkane, alkene or alkyne. Okay, is this clear? Okay. The next one, this one is the last one, secondary suffix is there. That indicates what is the principal functional group. What I am saying? It means there are different functional groups, like it can be carboxylic acid, it can be alcohol, it can be amine, it can be aldehyde, like that we have different, no? So IUPAC is given that there is some priority order. Means if one person is there, to him we should prioritize first, then the others. Okay, based on their priority order. Okay, so like carboxylic acid is the highest priority. Okay, and if like example, there is a carboxylic acid and there is a hydroxy group. So who should number first? Like that. That is become no principal functional group. I will show some examples. But is this clear? Okay. Now, tell me, what is the name of this compound? Fast. Done? First. Tell me. So from where we should number it? So this carbon, 1. So which side I should go? This side or this side? Down side, because alkene is there, no? So 2, 3, 4, 5. So tell me now. Okay. So, ఇప్పుడు ఈ స్టేట్లో కొందరికి కన్ఫ్యూజన్ వస్తుంది, అసలు సార్ ఎందుకు ఇక్కడ నుంచి నెంబర్ ఇస్తున్నారు, ఇట్లా రావచ్చు కదా అని. ఓకే, ఐ విల్ టెల్ యూ దట్ ప్రియారిటీ ఆర్డర్. ఐఎమ్ కన్సిడరింగ్ దట్ యూ పీపుల్ మైట్ బీ హ్యావ్ సమ్ ఐడియా ఆన్ IUPAC name. That's why I'm writing this basic thing. I think every one of you have some idea. Okay. If not, just hold on for some minutes. Okay, yeah. So like this we should number it. So now tell me how to write the name. What is the word root? Pent. And it is cyclic now. So cyclopent. What is the substituent we have? Methyl group. What is the principal functional group we have? So this is secondary suffix. Okay, now what is the primary suffix? In. Perfect. So I should write it as 4-methyl cyclopent 2-ene 1-ol. That's it. Okay, now tell me, this is methyl group is secondary prefix, cyclo is primary prefix. What root? Primary suffix. See, it is like not like it is not mandatory to remember that prefix, suffix, primary, secondary, but if you have that structured learning way, it is easy. Okay, now anyways you got everything clear now? Yeah. So now tell me, there are the things you have seen. One is a secondary prefix, that is nothing but substituent or position of that whatever the substituent we have. Next one is primary prefix, something like cyclo, bicyclo, spiro, I told you. Next, word root, number of carbon atoms in the given parent chain. Next, saturation, like alkanes are called saturated compounds. What I am saying? So let us understand this meaning, like after some days, alkanes are saturated or unsaturated? This is a confusion most of the students will have. Now let me tell you. Ethane is saturated or unsaturated? So how can you understand this? See, alkanes are unreactive or less reactive. Very less reactive. Who is very less reactive? alkanes are very less reactive, I am saying. Okay, when I am considering alkanes, alkenes and alkynes, both enes and ines have at least one pi bond. Okay, so due to this weak pi bond, they will show some chemical reactions. Okay, it means they haven't got saturated now. What do we mean by saturated in normal terminology? Arey, that fellow becomes saturated. It means he got exhausted. So he can't react more than that. So this fellow, like alkanes, they're very less reactive, means there is no reactive site. It means they got saturated. Okay, so remember now. Alkanes are saturated. Alkynes and alkenes are unsaturated. Just remember in that way. That's it, done. Next. Main functional group. Okay, right. Write it fast. You want little more complication? Right. Yes, tell me. Done? Okay. So from where we should start? I told you that main priority functional group is so it also have carbon now. So what I told you, you should number start from carbon side. So here we have carbon now, so we can number it. 1, 2, 3, 4, 5, 6. Now tell me. See, there are 3 functional groups, but only one is a principal priority functional group, first priority. Remaining whatever may be the functional group, that should be written first. I mean, that should be written as a prefixes. Only that functional group, priority functional group comes as a suffix, last one. Okay, that's it. Secondary suffix, exactly. Okay, now tell me. 4. Tell me 4 amino or 2 hydroxy? Follow alphabetical order, not numbers, follow alphabetical. This is a, like amino, okay, A, hydroxy, H. So who comes first in alphabets? You know alphabets, na? Yes. So which comes first? Amino, 4 amino. Okay, I will ask you one question. An alphabet we can drink. It's not a subject. Yes, T. An alphabet that can bite. B. Okay. Okay. So 4 amino, 2 hydroxy, 2 hydroxy, hexane acid. Okay. Done? Done. Okay. Almost done with IUPAC name. You have got some basic structure. Okay, before doing this, okay, let us do this. Yeah, tell me, how can you write this? Already we discussed now for cyclic compounds. So what to think first? Yeah, tell me what is the name of this compound? Yeah, 1 ethyl, 1 ethyl, 3 methyl, cyclohexane. So here E, alphabets, important. Okay. So tell me, which type of numbering is correct out of these two structures? Why second one? Count once. How many carbons are there? Same number of carbons are there. So what to do now? Not anyone, only one. That's why rules are there. Once again. See, that parent chain should have more number of branches. See, if I take this as a main chain, how many branches are there? This is completely one branch. This is completely one branch. But if you take this 1, 2, 3, 4, 5, 6, same number of carbons, one branch, second branch. Okay, more the number of branches, if same number of carbons are there in the parent chains, different long chains, the parent chain is that one which contains more number of branches. Okay, now tell me, consider it as an alkane and tell me what is its name. Fast. From where I should number it? From here or from here? Down. Tell me. So 3 ethyl. అరే చెప్పండి అమ్మా, బయటకు చెప్తేనే గుర్తుంటుంది, లేకపోతే అసలు అది ఏం జరుగుతుంది ఇంకా కనెక్ట్ కాలేరు మీరు ఆ కెమిస్ట్రీకి. ఎవ్రీవన్ షుడ్ స్పీక్ అవుట్. So 3 ethyl, 2 methyl hexane. Okay, fine. Next. Yeah, let us go little bigger. Okay. Out of these two, which one is correct numbering out of these two? Okay, if you read that statement once, you will get the idea. When the both direction leads to a tie in the lowest number, choose the direction that gives you first point of difference. See, 5 carbons in the parent chain. Now if I number it from here, I am going to get 2, 2 dimethyl, 2, 2, 4 substituent positions. But if I start from this side, so 2, 4, 4. Okay, so now tell me, first number 2, this is same. But next number here it is 2, here it is 4. So where it is smaller number? So this is called first point of difference. Okay, if this number is also same, then go for the next number. Like that. That is called what? First point of difference. Okay, now what is the exact, correct IUPAC name for this compound? 2, 2, 4 trimethyl pentane. Okay. This one. Done? Tell me. So how can you write this? What is the longest chain here? Do we have any functional group? No functional group. So longest chain you identify. 9 carbons is longest. Now number it from where it is comfortable, from here or from this side? From A side or from B side? Count the carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It is perfect. It is making us to feel easy. 5. Okay. 6, 7, 8, 9. If I go this side, 6, 7, 8. Which is longer chain? That 9 is a parent chain. So now this becomes what? Substituent. Now when there is a substituent which is having further branches. ఇంతకు ముందు మనం ఏం చూసినాం, there is only one branch like methyl, ethyl, like that single branches we have seen like this. If this is the parent chain, something like ethyl, methyl we have seen. But now if this is a chain, it has further substituents right now. So we can say complex naming here. Okay, so at which position this story we are studying about? Open like write 5 first, open the bracket. Okay, at 5th position, number it separately now. What is the chain like branch numbering? Like 1, 2, I can go this side, other side, everything is same. 3, okay, 5, open the bracket. So at 2nd position we have 2. So 2, 2, dimethyl, methyl, 1, 2, 3 now. See, it is not an independent chain to say propane. It is attached to this now. So what I told you? Propyl. So 2, 2 dimethyl, propyl, close the bracket. Propyl, and what is this name now? No name. Is this difficult? Just go with the systematic numbering or naming, you will get the answer. Okay, that's it. Okay. So let us create a question here itself. Yes, tell me for this. First write that, understand it, give name for this. Augustine, tell me. So from where I should start? This side, this side, this side. Where it is? Okay. This side? 1. Let's count. 1, 2, 3, 4, 5, 6. If I go this side. 5, 6, 7 this side. Okay, this is 4. From here also 1, 2, 3, 4. Okay, by default it is same. Okay. Next, what to do? 4, open the bracket. Array, from here, did I counted this carbon? Next, this carbon. 1, 2, 3. Here also 1, 2. So 1, 1, dimethyl. Next, 1, ethyl, dimethyl, ethyl, close the bracket, heptane. Are you getting this? Okay. So this is how the parent chain selection rule should be followed. What they are saying once, see? Maximum number of multiple bonds. Are you making small notes? No need of writing everything, just make small notes. It will be easy while you are revising or you are going to the material whenever it is. Okay, now tell me what is the first priority? Maximum multiple bonds. Okay, this is single bond, here multiple bond is there. So numbering should be start from this carbon, not from here. Don't leave this. Start it from the terminal side. Go end. Okay. Next, maximum multiple bonds. Next, maximum number of carbons. Maximum number of. Just now previously you have seen. Which we have taken? Maximum number substituents or maximum number carbons? Maximum number of carbons first. Next one is. If same number of carbons are there, then substituents. What is the priority? Full. Multiple bonds. Okay. Now write the name for this. Consider it an alkene, whatever they given. First, done. So from where I should start numbering? Which side I should go, this side or this side? Okay, this is 1, this is A side, B side, tell me now. What is that first rule? Multiple bonds, maximum number of carbons. So 1, 2, 3, 4, 5, 6. This side 1, 2, 3, 4, 5. Maximum this side, so A side. Okay, 1, 2, 3, 4, 5, 6. Okay, now tell me, this is a substituent. So 2, open the bracket, 1, 2, 3. 1 methyl propyl, close the bracket, hex 2, that's it. Clear? Sir, Magra. Okay, 1 in, fine. Just checking. Okay. So tell me, how many? So So what to do? Believe in? Yes. Okay, next. Yeah, so this one. First one is what is the principle, like we should name, first we need to give priority for the main functional group. Okay, first one we need to give the priority for the main functional group. After that, maximum number of multiple bonds. Next, maximum number of carbons. Next, substituents. Okay, so now what is this priority functional groups, the main functional group? See, we have different functional groups like this. So what are the list we have? Carboxylic acid, sulfonic acid, acid anhydride, esters, acid halides, amides, isonitriles. Okay. First one is what? Carboxylic acid. Next one? Next? Next? Okay, okay, okay. So now if carboxylic acid is there in the given functional, in the given compound, and along with that, if any of this functional group also present, then all other functional group whoever present along with the carboxylic acid becomes prefixes, but this fellow becomes same story applicable if there is ester and other functional groups, this below functional groups are there. So ester is our principal functional group, other becomes prefixes. Is this clear or not? Yeah. So now when we are writing prefixes, okay, if carboxylic acid is there, it should be written as carboxy. If you are writing it as a suffix, okay, sulfonic acid, sulfo is a prefix, sulfonic acid is a suffix. Next, if there is amide, carbamyl, okay, like that, please go through these lines. If there is aldehyde, you can write formyl or oxo, okay, for even for ketone also it can be oxo or keto. Just remember these names because multiple times it is repeated. Functional suffix for aldehyde is on. Okay. Now what is the main thing here is remembering their priority order. Okay. See, you can make your own mnemonic, but I can give this. It's your wish to follow. Okay. What it is saying? Clever student, clever carboxylic acid, student sulfonic acid, always acid anhydride, enjoys esters, having, as having means acid like acid halide, acid like having amazing over, acid halide it is over. Next nitriles, nites, in isonitrile, a K kind ketones, old alcohols, ols, town, thiol, sh, after amines, T, what is that? Okay, that's it. Up to here it is fine. Okay, so you can just go with this mnemonic or anything, but finally what you need to do? Find like remember that priority order. Okay, fine. So remaining things we will discuss in the next class. Firstly, tell me, are you following the class? Connect అవుతున్నారా? అసలు is it going into